Okay, well, I guess we'll make a start. And so my name is James Tan. I run a company called Digital Confectioneers. I'll just introduce myself a little bit and what we've sort of been doing. We were founded back in 2007, so we're about 10 years old this month, which is, yay, it's awesome. We were contractors for the first 8.5 years. We were working for Epic, and we also started working for other groups like Microsoft as well, pretty recently. But we kind of stopped all of that 1.5 years ago to focus mostly on depth in our own products. So we were finally able to break those proverbial chains of contracting, which we're really happy about. Our current mission is to make high-quality Unreal Engine games for PC and console soon, TM. We don't know when that soon is, but hopefully it'll be soonish. So this talk was really inspired from what we've actually been doing with Depth, which is a multiplayer PvP game on Steam. We released that back in 2014, and we're still making updates to it 3 years later. And we get asked that a lot on our Steam community whenever we go on sale. People are constantly asking, hey, do you guys still update this game? And a lot of the lessons that I'm going to talk about today was us transitioning Depth from a product to a service. It was extremely painful for a lot of reasons. And the reasons are because, one, we didn't expect Depth to actually still be alive today. And because of that, we made a lot of rash decisions when it came to how we would architect a lot of our systems. So what this talk is really going to go on about is looking at ways we can increase productivity so that you can constantly ship updates. For Depth, we ship updates every 8 weeks, so it's very, very tight scheduling. So often what we have is, in the 8 weeks, we have to start preparing all the art content that's required. We've got about 5 weeks to build that. We've got about 4 weeks to build all the engineering, because whenever we make changes to an old code base, we have to QA it for a long time. And then halfway in between that as well, it's sort of 4 to 6 weeks within that 8-week update cycle, we have to start preparing sprints and planning and all that sort of stuff. So there's very little room for errors, and we just found that, okay, what are some things we can do to increase our productivity for the next set of games that we make in the future? So Depth has done very well for us. We've sold 1.08 million copies, which is awesome. No bundles or giveaways. I encourage you, if you are releasing a new game and you're thinking of bundling straight away, come and talk to me after this. I will give you lots of good reasons why you shouldn't do bundles and why you should probably not do giveaways. We've done 966,000 units of DLC, 183,000 units of MTX, or microtransactions. The reason why DLC and microtransactions are different is because DLC is just something people buy once. They buy a skin and that's it, they've got it forever. Whereas MTX, or microtransactions, which is why we're shifting it from a product to a service, is usually things that people buy again and again. So that might be treasure chests, for example. And we're still very happy because we're still lucky that we still get into the Steam global top 10 sellers every single year. So for a game this old to still get there, we're pretty happy with that. So after this talk, I'm more than happy to talk about my experiences with that, anything outside of this talk. Okay, so I'm going to jump into 3 topics today, and if these 3 topics don't excite you, then feel free to join another talk. So we're going to talk about using external data sets and what that means, and we're going to talk about automated testing, and lastly we're going to talk about customizing the UE4 editor to make tools and customize it in such a way that it's really easy for you to do your own stuff and make it quicker for you to build things and push towards making your games into a service. So at DC we use JSON exclusively for a lot of different things. We find that JSON is really easy because it's human readable, so anybody can open the JSON file and just do what they want with it. And it's also got a schema attached to it, so as you write how JSON is going to be parsed in your game, you can append to your schema to say this variable is for this and this variable is for that. So as designers or non-programmers are working on the JSON file, they can always look back at the schema and remember, oh, this is for this and this is for that. It's easily diffable, So a big problem that we had with depth, which was built in UE3, was that you can't diff the archetypes that we would often make. And so we then shifted from archetypes. Should I explain what archetypes are in UE3? I probably should. Okay. So archetypes are a binary blob of data which acts as a template for an object. So if we wanted to make a new skin, for example, we had to create an archetype that contained the data for the skins. You know, what materials it used, or what textures it used, what sounds that skin uses, and so forth. When somebody wanted to change or tweak some values for that, the change would happen, and we would just see it in our SVN as, I changed this and the package name. We couldn't diff it because it was binary, so we had no idea what anybody did. So if there was a problem with the skin when we released it, we couldn't really figure out what happened and what went wrong because we couldn't diff it. With JSON, you can diff it because it's just text. So it works really nicely with SVN diff or Perforce diff or whatever other source control that you're using. It's very fast to parse, so it's not quite as fast as using a binary blob of data because you can't just shove it all into memory. But it's fast enough, and especially when you're dealing with when we tested it on PS4, Xbox, and PC, you really don't see any performance degradation by using JSON as your main data set. There is a free MIT licensed C++ third-party library. It's called RapidJSON. If you decide to go down this route, I highly recommend that you use that. There are reasons that I'll go into in the next page. There is also a Epic C++ library if you want to use that instead. So, you know, Epic has written one. It's lightweight enough for network communication. So with depth transitioning to a service, we had to build our own matchmaking services. We had to build our own, we have our own quest system. We have our own exchange server. So the quest system, somebody logs into the game, they get a new quest for the day, and they can do them as they play the game, and they get points associated with that. And we use JSON just to communicate between the two servers. With matchmaking, it's the same thing. We use JSON to communicate. And it's industry supported by lots of other languages. So what we're doing now as depth is sort of growing into a bigger and bigger game with more moving parts, we're having to hire infrastructure developers, for example. And infrastructure developers may not necessarily know C++ or C#. They might be more comfortable with something like Go, or they might be more comfortable in something like TypeScript, for example. But at the end of the day, you can use whatever you want, whatever you're more comfortable with. If you really like XML, or if you really like JSON, those are all sort of interesting languages or data sets you can also use. So why do we want to use external data sets, and what's sort of the flow? So what we found with depth is that we needed to have here are three primary data set examples. So we needed localization data sets, because what would happen is that, so depth is translated into about, I think, 11 different languages, and we primarily use OneSky to do all of our translations. And what you don't want to do with translators is to send them a big text file that just has the name of the localization that you bring into the engine equals whatever language. You really don't want to do that, and the reason for that is because it's incredibly slow for the translators, and often they will make mistakes. A really interesting mistake that happened in depth was when we translated to Japanese, we had the word bloom in it in our settings, and because we didn't provide context with that word, they literally thought it was flowers blooming, not bloom as in the rendering effect. So we realized we need a localization data set, which contains JSON data which we can import directly into OneSky. And that allows all the localizers to then just go through and get all that information about what that text is meant to be and so forth. And it gives them context. The other one was, we had a skin, it was called Blue Lancer, and some of the translators thought when we said Lancer, they thought it was the car, and so they translated it as, this is a blue Honda car or something like that. And so, you know, and we didn't read the language, we couldn't understand what the language was because we trusted them. But when we heard from our players, they're like, why have you got a skin called a car when it's obviously a shark? And And then we found out, we talked to the translators and they said, well, we didn't have any context. We couldn't see what the skin was. We just saw blue Lancer in English. So pricing data set. So a lot of us who make Steam games, we tend to just see one page where we just set discounts or we set our initial prices. When you start doing microtransactions, you start needing to provide sort of the prices for those microtransaction items. And the reason why they're so complicated is because you've got different regional pricing, but mixed with regional pricing, you've got things like trading. So if somebody from China buys a skin for $1 and they can trade that skin to somebody else in America where the skin sells for $3, you've created a sort of like an uh-oh problem. But it's also about managing how you want to split prices for things that can't be traded. So ideally you don't want to store them just in your game and then find that you need it somewhere else later on. And then there's the game data set. So the useful thing about the game data set is, it stores what all your objects are, what all your weapons are, what all your skins are going to be, and so forth. We take those data sets and run it through a parser. That parser can be coded in anything. It can be coded in TypeScript, PHP if you really like that, and anything you want. And then they get split up into 3 different things: client, server, website. This is just an example. So for your game, you might have more data sets, you might have less, and you might have different things you want to output to. So we didn't do this for depth. And the reason for this is because we weren't thinking way towards in the future. And so this is one of the lessons we learned. When we wanted to build the website, we realized, we actually had to just copy and paste the strings across. And inevitably, in every single patch, when we release or change numbers, what would happen is we would forget to update the website. We'd be like, okay, we go in and we hack up the website so it shows the right numbers. But it's not a really good impression for players who first jump into your game and they see totally different numbers in the game and totally different numbers on your website. And in the age of Steam, with Steam refunds, that first impression really, really matters. So, I talked about RapidJSON. Why should you use that? It's incredibly small, but it's feature complete. It's extremely fast. It's comparable to measuring the length of a string. It's a self-contained and a header-only library, so you don't have to compile a little C++ stack and then statically link it and whatnot. It's just all in headers. Memory-friendly, it's Unicode-friendly, it's cross-platform, it's cross-compiler. I've compiled this on Xbox and PS4, and I have compiled it on Android, and it just works on everything, so it's fantastic. There's no STL or boost involved. Whenever a library has boost, it's always a pain in the ass to... You guys don't mind if I occasionally swear. I try not to do that, but it just slips out every now and then. But yeah, boost is a real pain in the ass, so it doesn't have that, which is fantastic. It doesn't throw C++ exceptions when things go wrong, which is awesome. I really hate libraries that in debug mode they throw exceptions, because you'll be debugging your game and just all these things will pop up on the screen. It's really frustrating. It doesn't use C++ RTTI, which is the runtime type information stuff, so it's nice and speedy, and it's 100% standards compliant. So we use RapidJSON because we found that when you're transmitting data from a server to a client, depending on what the client's connection is like, sometimes you get mangled JSON. And if you write your own parser, which I don't recommend you ever do, but if you write your own parser, which is what we did, which is why I don't recommend you do it, you have to make sure that the JSON is actually valid, otherwise you just get hard crashes, which is what happened with us. So, yeah. So, now we'll jump into the meat of it. So, JSON as a property store. So, this is the easiest example to set up. So, JSON is used to store simple or complex property data. So, you can tell it to, for example, in my example, I've got a little duty. I've got the strategy game example, and it has a bunch of prices on the buildings that you can buy. So that's an example of just some simple data that you might want to change on the fly. And depending on how big your teams are, you can just hand this off to a designer and just be like, here you go nuts. Change these to whatever numbers feels right. They can go away. They can do A/B testing if they want, or whatever else. And the reason why I bring up A/B testing is because having those data sets and having those parsers means you can have a primary data set which says this is the cost for group A, this is the cost for group B, and when you run it through a parser, it can specifically generate all the JSON files for group A and then for group B, and you can store all those numbers in one data set and your parser just filters all that out. So that way your designer can keep a nice historical record of everything that he or she has tried in the past. It's best used when game functionality is really strictly defined. You just sort of go, this building costs X amount of dollars, it won't ever change, there's no complicated formula behind it. So the building doesn't go, oh, if you have this upgrade then it costs half less, and so on and so on. And it's extremely simple. So we're going to jump into some code and have a look at this. I'll just briefly run down what we do in the code, just so it doesn't get too horribly confusing. So UObjects, which is the basic object type in Unreal, they all have a function called postload, and when this is called on the default object, so in Unreal Engine, every single class is instanced as a default object. This acts as the template. So when you create that object or spawn an actor, it copies those values from the default object and puts it into that instance. This is coincidentally why you can't have pure virtual functions in Unreal. It's because they need to be able to instance those objects. So you can do two things from here. You can either modify UObject postload so that every single object in your game has JSON capability. This would require modifying your engine. And the other method you could use is to override just UObject postload in your subclasses. So if you need everything to have JSON reading capabilities, you do the first way. If you just need it for some things, you do it the second way. So how does this all work? So, in this sentence I've just said, iterate over UObjects, UProperties, declared properties, find matching JSON property and set. So it sounds really simple. To dive a little bit into how this actually works, when you declare UProperties on C++ properties, this is how many people in this room have been told that Blueprints is actually based on Unreal Script? No one? Okay. So the origins of Blueprints comes from Unreal Script, kind of. So the virtual machine for Unreal Script still kind of exists in one form or another. And the interesting thing about that is that, so when you declare the properties, you can actually iterate through them in C++, and you can do all kinds of things you want with them. So when you find a property, you can do other things to optimize this step as well. You can add your own meta tags to them. So you can say, here are a list of properties that I will allow designers to change. Or you can just say, any property that the designer wants to override, he can. That's totally fine. Then you find the matching JSON property, and then you just set the value. So if the object happens to be an actor, and the JSON happens to point to a uComponent property, you may need to call certain functions to set those properties. So an example for this is anything that derives from a scene component, you can set the scale of it, but you need to do that via the setScale3D function. So, and after you do that, you're done. Okay. So I'm just going to jump into Unreal and so show you this in action. So what I have here is I've got JSON templates for all three buildings that you can build in the strategy game example, and I've overridden a thing called cost. So we can change these values if we want to at any time. And I'll just while I wait for Unreal to boot up, we can have a look at the source code. Okay. Okay. Okay, so I've created a static function called load.json. It takes in two parameters, an object and a JSON file name. So in here, you've got a lot of, the nice thing about Unreal is that it comes with so many functions that just let you do lots of different things. So there's a helper function that can just load the JSON file and dump it all into one string. Once you have it in the string, you can get RapidJSON to parse it. You can then check if it has any parser errors. So maybe in your test builds or your debug builds, you might want to have an else and then say, you can ask RapidJSON, where did the parser fail? So you can actually report to designers, hey, you forgot a curly bracket here, or you forgot the comma, or something like that, which is super nice. And here's the property iterator I was talking about. So for every object, you can iterate through all of their properties. And then for every property, you can look up the names, you can look up the values, you can do a lot of things with them. So here's what I was talking about, checking to see if the property points to a component. So if the object property, you cast it into UObject property, if that returns a valid pointer, you can grab the value of that object and you can then cast that and see if that's something else. And here I run a recursive function which tells it to say, hey, load the JSON data that's associated with this object property. Otherwise, here we've got this magic line here called import text. So import text is a super handy function in that all the different subclasses of your property override this, and you basically give it a string value that it accepts, and once it accepts that, it will set the value for you automatically. And the nice thing about this is that it works on all simple types, so integers, floats, strings, and so forth. But it also works on all complex types as well. So you can have array definitions and struct definitions. You can have arrays within arrays. You can have structs with arrays in them, with structs in them, and so forth. It doesn't matter how complex you get it. You just need to use just this one function to do it. Okay. So we have the strategy example booted up. Okay. Okay. So in here we've got all the prices. So from here we could probably just change all the JSON to do whatever we want. Sorry about the speed of my laptop. It's running on battery, so it's downclocking itself just a little bit. There we go. So you've got instant access to the changes, and your designers can go nuts. And the nice thing is that for designers who don't want to have to constantly put up Unreal Editor just to change one value, they just go into the JSON and do that there. The nice thing about this particular system is that it's a cascading effect. So you can define the property values initially in C++. Unreal will then look for an override in the blueprints, and then this code will look for an override in JSON. So initially, the engineers can write an initial value that sort of kind of makes sense to make things work. A blueprint designer can then go in and set another value, but then sort of another designer can just override that using JSON. So you've got these nice sort of onion layers to how you want to develop. And that's really worked out well for us when we're developing our future titles, because the engineers can just do something so that people who then have to do QA can start queuing and go like, okay, I see this value and the system works. And then you pass it over to designers and they can just do what they want from there. Okay, so JSON as an object class. So this one's a little bit more complex. So JSON is used to store simple and complex data and to define and specify object class and components. So this makes it really easy to generate new game objects without having to modify blueprints or C++. So one of our future projects, we're going to have lots and lots of items. I guess you could say it's very similar to an ARPG. So you're going to have 50 different axes and 100 different swords. And you don't really want to have to, make new blueprints all the time. You could, but it can slow things down. And also designers might not want to do that. Maybe they just want to make one file in JSON and just say this is a new axe. So it's a bit harder to set up though. That's the unfortunate downside with that. And it's a bit harder to network as well. So, and if you've got a networked multiplayer game, you need to tell the client, hey, I'm spawning this object based on this JSON. So you need to figure out a way to do that. Okay, so the way that works is you have to load the JSON first. Once the JSON's loaded, you can grab the object as the UObject class as set in JSON. You then instance the object or spawn the actor, and you set the UObject properties. You can then decide to instance UComponents. So for example, if you've got JSON and it just spawns sort of an empty actor as such, in your JSON file you can say, and I want a stack mesh, and I want a skeletal mesh, and I want this and this and this. So this is really important to us for future titles because if we want to make skins that have extra particle effects or extra meshes on them or so forth, we can just do it all in JSON. We don't have to constantly dive backwards and forward between blueprints or C++. Once you've instanced all the UComponents, you can set all the UComponent properties and then you're done. Okay. So in the strategy game example, they have a strategy AI director which instances all the little dudes that walk on the map. And I've just overridden a certain area to do the thing that I just mentioned. Here we go. So I have a little helper function here called getJSON class. So I'll show you what that looks like. There we go. So all we're doing here is just loading up the JSON file, we're just parsing it really quickly, and then we're just saying, hey, does this JSON document have a member called class? And if it does, then load the class name up. You can grab the class, and once you've got the class, you can return it. So I'll show you what that JSON file looks like. It looks like this. So here we've got a class definition, and it happens to point to a blueprint. The one thing to remember with blueprints is that the blueprint and the class it generates are different objects. So if you want to point to the class generated by the blueprint, you have to add the _C. That's where that comes from. Okay, so back in AI Strategy Director. So here we've got the class, and down here it just spawns it as per normal. So we're spawning it down here. And then, once it's been instanced or spawned, we tell, hey, now load the JSON. Okay. So this particular JSON file is an example of why we want to use sort of a primary data set and then use a parser to convert that into a secondary data set. You've got things like this. For example, I can change the scale if I want to, and that's set up in a very JSON-friendly way in that you've got a property name or a JSON property name, and then you've got an array with 3 values in it, which in this case represents the 3D scale, the X, Y, Z. But if you try to import that directly into Unreal, it doesn't actually like that. It prefers things as sort of a collapsed string. And then up here in this pawn data, That's also, this is what Unreal expects you to do, and that's what I meant by a collapsed struct, or a collapsed sort of data set. But it's not very nice from a JSON point of view. You know, it's just a single string. You can't really write nice comments in the schema to say, hey, this is what attack min does, this is what attack max does, and so forth. If you had a parser, what you could do is you could write it in a nice JSON way in your primary data set, parse it to generate the string that Unreal can then just, or RapidJSON can then just import. Okay. So from here, it's the same, very similar example in that I can just change these values at will, and it'll just do different things. So here's the little dude spawning across in the map. Maybe I should have shipped my PC here.
There is a PowerPoint in the wall if you want to.
Oh, it's still just a Surface Pro, so it only goes so fast. All right. So we've got our little dudes, and eventually when the wave starts, they'll start spawning. Okay, so we've got little dudes here. You can change some fun values. So how fast should I make them go? From 0, so they run, so this is the additional speed that they run at. Does somebody want to just throw out a number? And 500. Good value. And what size should we make them? Right now they're that little tiny size that you saw just now.
42.
42. All right. 119. All right. This is. I asked for numbers, so however it turns out, it's not on me. Okay. Okay. Yep. Okay. But hey, the JSON stuff works, right? So, you know, at least we got that going for us. All right. Just to sum up with the JSON stuff. So basically, yeah, avoid just writing JSON directly for your game, like I did in my example. So I'm already a bad example, so don't do that. But you know, you might need to store additional data related to the object, but isn't relevant to the game. And this comes up a lot when you start doing multiple platforms. So for example, if you're making a strategy game and you know that the platform's going to be PC, you know they're going to be using a mouse and keyboard, so there are a whole bunch of things that you don't need to tweak. For example, their bound size might be, you know, pretty reasonably tight because you know that they've got a mouse pointer, so whatever. But if you're bringing that game to touch screens, maybe you need a different set of data for your touch screens, and you have your parser go, oh, this is the touch screen version of these files. Okay, I'll implement different data sets. You might need localization. So if you're generating data that goes out to a website, or if it goes into your game, and they happen to share the same localization strings, super useful. Where this comes up very often in depth for us is when we do patches. Often we want to start introducing the next patch relatively soon, so we want to have very similar sort of hype text in the game for the next patch. But we also want to have that on our website, and we may also want to have that on the Steam store as well. And so again, this is one piece of text that needs to be in 3 different places. You might need different output between client and server. Maybe you want to secure your game in some way or another. And so you go, okay, that means the server is going to know more details about things. So for example, it might need to know web API keys. It might need to know about secret hashing algorithms, salting, or whatever else. but you don't want that information releasing on clients. And again, parsing will help solve a lot of those issues and also reduce people's mistakes. One that came up really often, and this is why we instituted it, whenever we got new infrastructure developers in, they would actually write the web API key in SVN, but contractors also had access to the SVN, so now they knew all our web API keys, and that was not great. So you may need to output to different platforms, which I mentioned. So this point here, import text, it can import complex data types, as I said. It can also import UObject references, so you can point directly to a state mesh, or to a skeletal mesh, or to an entry, or float curves, or whatever other kind of data you want. But the formatting is not really easy to write. It's not really easy to check. So a parser can validate a lot of those things. So if a designer says, I want to point it to this stack mesh, and your parser can actually scan the Unreal Engine content folder and be like, does this thing actually exist? And if it does, then you can say that's fine. But if it doesn't, then you can at least throw a warning to the designer and be like, hey, this thing doesn't exist. Did you get the name right? And so forth. The nice thing is that you can actually pair this up with commandlets, which we'll get into, to actually then go deeper into analyzing your objects in the game. So at DC, we use TypeScript to write our parsers. We find TypeScript is just a subset of, or it's a layer on top of JavaScript. So nice and easy to write. Lots of people are pretty familiar with it, and even if they aren't quite familiar with it, it's very fast to learn. And you can include your parsers as part of your cooking step or localization gathering step. So again, if you've got Jenkins set up or something along those lines, you just say, before you do a cook, parser, generate all the data that you need as a fresh set, and then do that. And that way you don't constantly have to go, because this happened to us, in that every time somebody generated a new script, there'll be an SVN commit that just goes, oh, I just generated these things. And so waste a lot of sort of the build master's time having to look over the SVN scripts and realize, oh, that's not really necessary to include. So, all right, we're going to jump into automated testing. And again, after this talk, you can come and talk to me about anything about JSON. We definitely learned a lot while we were developing depth in our future projects. So, complex projects. So depth, its first line of code was written back in 2009. So we've got code that's 8 years old, and not all of it's great. And there's lots of stuff that's moving around, and we try to centralize systems and so forth. We actually have 3 different skin systems for the weapons, for the divers, and for the sharks. And you might go, that's crazy, and it is. It's really, we want to centralize that, but it's been really difficult to do that because lots of moving parts. If you're rapidly expanding your team, it allows, what we found when we hired graduates is that they would often be really scared to modify code. And they would be even more scared about submitting things for code review. And this created a lot of tension in the company. And as we started introducing automated testing, it meant that these guys or girls could run their code through an automated test. And if the automated test said everything's fine, they could then submit it for code review and not feel that nervous about breaking the build at 3 AM in the morning and then they have to bring in donuts for everyone the next day. So we also recognized that when we wanted to think about automated testing, we have to make it easy enough for QA and test engineers to actually create the tests. So when we think about the development workflow, we tend to think, okay, community or somebody has found a bug, they need to generate the repo steps for us, and then they just send us a Jira ticket. But we wanted to go to that next step, and instead of just saying, generate the repo steps for us as a list of things that we have to do, we now tell our QA people to actually make those tests for us so that they can reproduce it there, and then we can just build it up and go, oh yeah, okay, we can actually see the problem. Per patch release, you can test builds for hundreds or even thousands of hours before release. This came up in depth a lot, and the 2 patches ago when we patched depth, we had to make 4 hotfixes. And hotfixes are bad because, one, it gives customers a really bad impression of your product because they eventually start writing negative reviews that say, you know, you guys keep hotfixing the game, just do it right, do it right the first time. And so that felt really bad for us, and also felt bad for our QA team because they took personal responsibility for letting those bugs slip through. But when you've got a really complicated game, and if you've got something even more complicated than just a diver versus sharks kind of a fighting game, and you've got, say, an RPG or an MMO or anything like that, and you've got to test all the systems, it can be really difficult. It allows anyone to feel pretty comfortable refactoring or rewriting systems and just use the same tests. If the tests are done in a nice, easy way, then if you rewrite, say, the skin system, it can just run through all the skins and take a screenshot at each time it loads one up, and then you can guarantee, okay, these skins are still working. This is going more into the biz dev side of things, so there are two aspects of business that I often call, say, the front end and the back end. The front end is when you're talking to customers and saying, hey, buy my game, it's great because of this and XYZ, and there's other stuff in the front end, but the back end side is more about, we need to improve our product, or we need to increase efficiencies. And we're at the stage now where we feel pretty comfortable with people buying the game and how fast they're buying it, but it allows us time to look at the back end. How can we improve things? As an example of real world dollars, so we had the Quest server up and people were playing and so forth. That server cost us about $5,000 a month. We added one extra line to our SQL statements, and that dropped that price from $5,000 to about $2,000. So from that point forward, we were saving $3,000 every day. Those are the kind of back-end improvements you can do. And with things like automated testing, you can do more of that and feel more confident. I know this may not seem like it for anyone who's quite small. At least I remember it 10 years ago when I was really small. But the reality is, hardware is extremely cheap. Time and labor isn't. It's super expensive. Remember, for entrepreneurs, always be frugal, but don't be cheap. So be frugal in that make good purchasing decisions or spend your money wisely, but don't say, oh, I don't want to spend this because I've only got $100. But if you can spend $90 and get $110 back later because you've made those expenses, it's always a good idea. So I know automated testing might sound expensive, but it is well worth it. So this is the dev flow that we were talking about. So there are generally two paths that we now follow. We develop a feature, we try to write an automated test for it if we can. So if it's a mathematical function or if it's a simple command system or anything like that, try to write the automated test as you're developing that feature so that as you develop that feature and then go, okay, now we have automated test, you can constantly keep running it back and forwards until you get it right. And then we add the automated test to the automated testing list. So this goes into a big list and we basically just run that all the time. For QA, they find a bug or community reports a bug, they create the automated test and we then fix it, and then we run the automated test again to test if the fix works. So the reason why we add these automated tests to automated testing lists is so that we can do full regression testing. There's nothing worse than building a new system or fixing the system and then having to, going back and realizing that you've regressed an old bug and it's come up again. So if you're using Jenkins or some other sort of scheduling type service, you can use that to basically have just machines just sitting in the corner somewhere constantly running these automated tests. Optionally, you can get Jenkins to schedule these tests as well. So if a new person joins your company and says, how do I do this? You can just say, hey, go to this web page. Jenkins has a big button that just says automated tests, and you just click on that. Super useful. Okay, so we're going to have a look at the automated test code and automated test blueprints. So Unreal Engine comes with an automated testing framework that you can build on top of to add extra things to it. So on top of that, I'm not going to go too deeply into the code, but we just have a lot of helper functions. One, to set up the tests, so maybe spawn all the actors that you need. So for example, if we were doing an ARPG and you want to test drops to see if drops were working, you can spawn a player or a player character, and you can spawn the drop on the ground. That would be your setup phase. And again, automated testing can actually test if this fails, because if your character fails to spawn, or the drop fails to spawn, and the setup goes wrong, you can immediately throw an error and be like, hey, automated testing, this already failed. So you can then start the test, which is basically if you're going along the ARPG examples, you might have like a command list to send to the character to say, hey, walk over there, and then when you get over there, pick up this drop. And then we have an update loop. So basically that runs every single tick, checking the state of the automated test, and checking to see if anything's failed or anything's succeeding. And then we have a cleanup. So the great thing about the automated test framework that comes with Unreal is that you can run lots and lots of tests, all in the big sequence. But you'll need to clean things up. So other than that, we have just a whole bunch of helper functions, adding errors, adding warnings, adding logs, and that way it just sort of helps the QA or test engineers to sort of build nice automated testings where they can actually not only test the bug or test a fix, but they can also test their own automated test, which is kind of interesting. Okay, so I'm going to jump straight into the automated test to quickly show you what that looks like. So the blueprints themselves, they're in a folder called tests. We have a couple of them here. I'll just see if I can increase the size of those. Okay, so I've got a test here to test character movement. And in here, it's super simple. I don't know how to zoom without a mouse, unfortunately, so I'll just go through it really quickly. Oh, that's how we do it. Can we do that? Okay, we can do that. So when we set up the test, we just spawn a character at a particular location, and what we anticipate in the update loop is we're basically just saying, has this character reached a certain area? So every update, we just check if the character is valid. We then go, is the character at a specific location that we anticipate? And if it is, we just say, hey, return true. And then in the cleanup phase, we just destroy our actors and then move on. So the handy thing is you have the session front end. This is what the automated test suite looks like. So from the automated test, you launch a standalone version of the game. And this is why it's actually really handy doing it this way, because if you've got a automated test machine that is fulfilling other roles, you might not always put a graphics card in it or something like that. So this can actually work across the network, and so you can have all your developer machines which have nice graphic cards in them and so forth, running the standalone version. The session front end then connects to it from your automated test machine and then does all the tests, and you can just do that overnight or whatever else. Okay, so now that we have that, we go back to our session front end. We've got that session. So that's the session that I've just booted up. We then go to all tests. So I've got a couple of tests here, and this was the test that we were just looking at. Spawn the dude, make sure he moves. When he gets to a certain location, you go, okay, that automated test has succeeded. So we can then start the test. Don't save. So it's spawned the dude, he's running across. Eventually he'll get to the spot where we think he'll go. The test is now ended. And so you get a sort of a log here, and this is where those functions I showed you earlier before, where it's add logs, add messages, and so forth. And so in this list, you've got a green tick. So you can tick as many things as you want to build to your list. So in this case, I've got an automated test that's always going to fail. So it's the same test, but the guy doesn't move. So in here, he's spawned the dude, he's not moving, and eventually the automated test will time out and be like, this test failed. And so you can set up automated tests in that kind of situation as well. And that way this works really well, because when you've given a lot of flexibility to your designers to just go crazy with all the JSON values and so forth, sometimes they might actually break something, and they may not even realize that. So here the test says it failed. And you can always select as many or as little tests as you want. There's also a lot of automated tests for Unreal itself, so if you're adding plugins or writing stuff to it, you can do that as well. Okay. Sorry, I'm just going to have to speed up a little bit because we're running a little bit out of time. But I'll go through editor customization. Do not be scared to modify Unreal. You've got source code access. Go nuts. Unreal has been built so that it's extensible through 4 main ways. You can write engine plugins, game plugins. The difference there is that if you have a central build of Unreal for all your projects, write an engine plugin where if it makes sense for multiple projects. Game plugins, so if you've got, if you need it to extend the editor in a very specific way just for that project, do it in there. You've got editor extensions. You can modify Unreal Editor's menus to add new buttons and so forth. And then you've got commandlets. So commandlets are super useful because you can pair them with other things. So in the case for our future projects, what we have is when we write JSON, we run through a parser. We then use commandlets to check if that data actually makes sense, if those properties actually exist, and so forth. You can integrate with other applications to make your life easier. For example, you can integrate with Jira, which is a bug tracking tool. And I would highly recommend that you build tools in Unreal instead of building them outside of that, because you'll have a much easier time to access all the data you want, say from blueprints, from stack meshes, and so forth. And again, you're an entrepreneur, so be frugal, don't be cheap. If it already exists in the marketplace and it costs $100, it's probably going to be much easier and more frugal to just spend the $100 and get a working thing straight away. Okay, so I'm going to jump into actor customization. So details customization is when you want to add buttons to the properties panel. And you can use this when you want to customize lots of different things. It uses Slate, and Slate is the UI framework that comes with Unreal. It can be used to run C++ functions, and it can also be used to run and implement blueprint functions as well. So if I jump back into here, I'll just close this. Okay. So in this, I have an item factory here, and what it does is that it places these little arrows, and I have this. These are the customizations that I'm talking about. So you can add buttons here, so you can do lots of different things. So in this case, if I click that, that will run a C++ function. If I click that button, that will run a blueprint function. I have to spawn the blueprint version of that. Sorry. So it's here. Item. Okay. So the nice thing about that is that you can actually create actors and then give to your designers. Okay, so apparently I'm out of time. Sorry, but how much longer can I go for? Next one starts at 12. Okay. Can I have like say 2 minutes? Okay, cool. So what you can do with this is that you can say to your designers, hey, you've got this tool here. You can click a button and you can do anything you want in blueprints. You can spawn actors. You can spawn different things. It's a really great tool for designers and level designers specifically. In one of our future projects, we're building an open world game, and one of the things that we wanted to do was to give level designers a really good, strong ability to be able to say, hey, place all these fences on this hill, and it just does all the traces, it sorts everything out, and that's great. You don't have to place them manually by hand. So I highly recommend building extra tools like that. You can also bind important editor events to simplify your workflow. So for example, with these item factories and how they spawn arrows, if I change these values, they'll change as I change them. If I move the item factories, they'll update automatically. And again, that's super helpful, and it just reduces that need for constantly iterating and going back forwards, or speeds all of that up. So, okay. Menu customization. Now I'm going through it really quickly, I'm sorry about that, but a lot of this data and information is also available on the web too. So you'll find a lot of tutorials. So in here, for my specific game, I have created a new menu function for strategy game, and I can tell it to update all the item factories, or generate item factories, or do whatever else I want. So again, this is just to help speed up productivity with the level designers and anybody else who's using the editor. You can also create linters if you want to make sure that people actually stick to a naming convention that you want to use in the editor. There is a marketplace tool written by a good friend of mine, so check it out if you need a linter. Commandlets, again, they're super useful. You can write them as plugins. They're C++ code. There is actually a tutorial out there available, so you can also see that. You can use them for just about anything. You can access perforce, so you can check out any number of things. You can submit all the changes that you made to them. You can access all the Unreal object types, so you can scan all your blueprints, for example. Check all the property data. Okay, thank you. Yeah, thank you. The last comment I was going to make to tie it all together, if you've written a whole bunch of JSON files, you can get a commandlet to scan all your JSON files, compile them into an object that you want to use for security purposes or something like that. So, thank you everyone. Thank you.
Thank you. Thanks very much.
Thank you.